Hello and welcome to the lesson Application of Differentiation KCC 2020 paper 1. The displacement s meters of a moving particle after t seconds is given by s is equals to 2/3 t cubed minus 7/2 t squared minus 6t plus 8. Determine a. Velocity of the particle when t is equals to 5, b. Time t seconds when the particle is momentarily at rest, c. Displacement s meters when the particle is momentarily at rest, and d. Acceleration of the particle when t is equals to 4 seconds. Now let's begin with the first one. The first one is velocity when the particle when t is equals to 5. Velocity of the particle when t is equals to 5. So how do we get velocity when given displacement? Now to get velocity when given displacement, we shall differentiate displacement. So velocity is given by when we differentiate displacement with respect to t, we shall get ds over dt, and this will give 2t squared subtract 7t subtract 6. So therefore velocity is equals to 2t squared subtract 7t subtract 6. So that is the expression for velocity. After getting that, we need to get the velocity when the particle when t is equals to 5. So we just when t is equals to 5, we just substitute t is equals to 5 in this expression for velocity. So velocity is equals to 2, where we have t, substitute that on with 5. So we have 5 squared subtract 7, that is 5 subtract 6. Working out these using a calculator, you shall get this will be 9 meters per second. So that is how we're supposed to do the first part of the question. Part B of the question: time t seconds when the particle is momentarily at rest. When the particle is at rest, the time when the particle is momentarily at rest. So at rest, when the particle is at rest, velocity is equivalent to 0. So what we shall do, we shall just take this expression for velocity. So 2t squared subtract 7t subtract 6, and we equate this one to 0. V is equals to 0 when the particle is at rest. Now you notice that this one will give us a quadratic equation. We need to decide on the best way to solve this. When I look at factorization, it will not be possible. Two numbers whose product is -12 and sum is -7. May not get that. So to work out this one faster, we shall use the quadratic formula. So the quadratic formula goes like this. So t will be given by -b plus or minus b squared minus 4ac, everything divided by 2a. Now in this case, a will be 2, b will be -7, and c will be -6. So let us work it out now. Having that, we can substitute. So t is equals to -b will be 7 plus or minus b squared will be -7 squared minus 4 multiplied by a is 2, and c is -7. Everything divided by 2 times a. This one will be 7 plus or minus, this will give 49, and this one will give 48. Everything divided by 4. This will be 7 plus or minus the square root of this will be 97. Everything divided by 4. This is equals to 7 plus or minus the square root of 97. This will give 9. We use a calculator to do this. 9.849, 9.849 9. Everything divided by 4. Now, after getting these, therefore, the first value of t will be 7. We take the positive sign. It will be 9.849 divided by 4. So, working out these, the first value of t, 7 plus 9.849, this will give divided by 4, give 4.212. Then the second value of t, we shall get that on by taking the negative sign. And these will give 7 subtract 9.849. This is a calculator, negative 0.7123. So those are the two values of t that you get, the two values of t. So you have the first one there, this one. So we shall ignore these. We shall ignore this one because it is not possible to get negative time. So we shall consider the positive time. So therefore, for that question, after using the quadratic formula to solve that, you get when the particle is at rest, that is when t is equals to 4.212. We shall not take the negative one. So the other question is on, let's see, part C. Displacement S meters when the particle is momentarily at rest. Displacement when the particle is momentarily at rest. So we have already established the time when the particle is at rest, is momentarily at rest. That is a 4.212 seconds. So we need to get the displacement at this instant. The displacement at this instant. So we're going to take the expression for displacement again. S is equals to 2/3 t, and copy this one, so cubed minus 7/2 t squared minus 6t plus 8. So to get the displacement and the particle is at rest, we just substitute 2/3, then substitute t is equals to 4.212 squared minus 6, 4.212 plus 8. So we shall use the calculator to work out these. When you work out these, 2/3 into brackets are 4.212 cubed minus 7/2 brackets 4.212 squared minus 6, 4.212 plus 8, you shall get negative 29.55 meters. Negative 29.55 meters. So that is the displacement when the particle is momentarily at rest. Now, after getting that, we can go to the next question. The next question where we have part D, acceleration of the particle when t is equals to 4 seconds. Acceleration of the particle when t is equals to 4 seconds. So how do we get acceleration? Now, to get acceleration, we shall differentiate velocity with respect to t. To get acceleration, we shall differentiate velocity with respect to t. So we need to get the expression for velocity. We already had that in the second part. 2t squared minus 7t, 2t squared minus 7t minus 6. So when you differentiate these, we get acceleration. So this will be 4t subtract 7. So acceleration is equals to 4t subtract 7. So when t is equals to 4, what will be acceleration? So acceleration will be 4 subtract 7. Just substitute t with 4, and this one will give 16 minus 9, so this will give 9 meters per second squared. And that is how you're supposed to solve that question. Thank you.